All right, so today I'm going to do a little clip on E and Z. All right, so while we get into elimination reactions, we have to be familiar with E and Z nomenclature because it does tie in with reactions in a way that we have to know how stable or how unstable a double bond is going to be. All right, and that ties into nomenclature as well. All right, so it's kind of things are starting to build in a way that we do need to be familiar with in order to take the next steps. All right, and this first step that I would like to touch on is E and Z. All right, we've heard of cis and trans before, which will still come up, but in terms of E and Z, all right, it's very similar in which I'd like to give you a little bit of an example. All right, so this first molecule here, let's just say we have that, okay? We would describe this as trans, typically, right? Versus cis, right? The highest priority on coming off of each end of the double bond are pointing in the same direction. So they're cis versus in opposing directions, trans. All right, so that was familiar from prior lectures and stuff that you've seen in class. That doesn't go away. All right, so this would be cis and trans. All right, and we typically use cis and trans versus E and Z when the things coming off the double bond are the same. All right, so that's a methyl coming off of that carbon. That's a methyl coming off of that carbon. So we're typically using cis and trans. But let's compare something like this that does not have both sides being the same. Okay, this is where we're getting into using E and Z. Okay, all right, so we typically assign priority per usual. All right, the things with the higher atomic number. All right, so coming off of this carbon, we're going to just do a dotted line. We're looking at this carbon here. We have the highest priority circled as the methyl, right? A hydrogen versus a carbon, the carbon's going to win, right? And if we're looking at this carbon with the arrow, all right, a hydrogen versus the ethyl is going to win. All right, so on the same side of that double bond are your highest priorities, and we're going to call this Z. All right, Z for same, sounds like same, if you want to put it that way. All right, E would be the opposite. All right, so let's just say, hypothetically, you were to just have this turned around. All right, now your highest priorities are on the opposite sides of the double bond, and so we would call this E. All right, so opposites are E, same side is Z. Okay, all right, but if the one side of the double bond, all right, has one thing that is the same as what the other side has, kind of like this example. All right, one side has a methyl, the other side also has a methyl, and that's it. All right, both sides of the double bond are the same. All right, then we can use cis and trans. But when we're getting into each side of the double bond having something different, then we're looking at using E and Z. Okay, and this comes directly into nomenclature. All right, so nomenclature rules will come up again. All right, but now we have to tie in E and Z. All right, so just a brief recap. Let's just say we have the following example. Let's just say we have 2,3-dimethyl pentane or pentene. All right, ene. Actually, So nomenclature wise, this describes that you have two methyls, one occurring at the second and the other occurring at the third carbon with a double bond. We know it's a double bond because our suffix changes. All right, to ene, that indicates a double bond. And where is that one occurring? At the second carbon. All right, so let's draw this out. Let's draw out our pentane as a straight chain just to get our parent molecule. 1, 2, 3, 4, 5. All right, we have dimethyl, 2 and 3, and we have a double bond occurring at the second carbon. All right, so that's just a little recap before we add in our E's and Z's. All right, so let's just say, for very basic purposes, let's just say we have E, 2 pentene. All right, so let's draw out our pentene. All right, and the double bond is occurring at the second carbon. All right, and we need to make sure that this is in fact E. All right, remember E is for the highest priorities being on the opposite side of the double bond. All right, so if we're looking at this carbon here, we have the methyl versus the hydrogen. It's down here, okay? Versus this side of the double bond, we have the hydrogen, and we have this ethane coming off of it. All right, so this ethane, this group is going to be of higher priority versus this group being of higher priority, and they're on opposite sides of the double bond, making this, in fact, E. All right, how could we make this Z, for example? Let's just say this would be Z. That's what it would look like. All right, the higher priority on one end is on the same side of the double bond as the higher priority on the other. All right, let's do a couple more examples. What can we do? All right, how about something a little bit more complicated? All right, let's just do Z 4R. Let's tie in some chirality. All right, 4 methyl, 2 hexene. All right, so let's draw out. So let's begin drawing. Okay, we need 6 carbons. All right, so here's 1, 2. There's going to be a double bond on our second carbon, indicated by our prefix. All right, and we need the thing on the other side of this. So you see this methyl is coming downwards towards the bottom half of the double bond. Okay, so we need the other side to do the same thing, because remember, Z for same sounds like same, so it needs to be on the same side of the double bond. You would continue the molecule as such. Okay, and then finish. All right, so this is 1, 2, 3, 4. 5, 6. All right, and we got a methyl on the 4th carbon. All right, and we need to make sure, again, this ties into chirality. We need to make sure that that methyl is going to be R. Okay, how do we do that? We got to compare what's coming off of that front carbon. So let's just say hypothetically that this is wedged. That's what I tend to like to do. All right, I like to put what I'm double checking on wedge first. All right. Let me just move this. All right, now let's assign priority. All right, here we have the carbon, 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 all right, and our implied hydrogen is going to be 4. All right, we have a carbon attached to 3 hydrogens compared to a carbon attached to a carbon, and a carbon double bonded to another carbon. That double bond is going to win out. All right, So this is gonna be 1. This is gonna be 2. This is going to be 3, all right? And like this little trick that I'd like to do, it's taught elsewhere, but this is also how I learned it. I ignore what's in the back, all right? I ignore what's dashed. So let's just say that hydrogen is not there, and we count up, all right? 1, 2, 3. Rotating clockwise or turning the steering wheel to the right, we get R. And is that what we want? Exactly. We wanted R, all right? Perfect. So this is, in fact, our appropriate finished product. All right. So again, E and Z does tend to tie in a little bit of nomenclature, a little bit of chirality, in which the puzzle pieces are starting to come together to create more complex molecules. All right. So you need to be familiar with how to go from the name to the structure, and just like how you learned in nomenclature, you need to be able to go from the structure to the name, right? So let's do that. All right, let's do structure to name. All right, so let's try this. All right, so let's try this name. All right, what's our parent chain? 1, 2, 3, 4, 5, 6. All right, so we know hex. And we have a double bond. All right, so it's going to be hexene. And would we start from this far side on the right, or would we start with the far side on the left? We want that double bond to take priority in our numbers. All right, so we want to start on the left-hand side. All right, so this is going to be carbon 1. This is going to be carbon 6. Okay, so we have a double bond occurring on the second carbon. So we're going to indicate that in our name. 2-hexene. All right, we have a methyl coming off of the third and the fifth carbon. So we're going to have 3, 5 dimethyl 2-hexene. All right, so let's put this together. 3, 5 dimethyl 2-hexene. But with that double bond, all right, we got to indicate is it E or Z. So let's just draw an imaginary line through there. All right, this methyl is up on the upper half of the double bond. All right, and what's of higher priority? This thing, this parent chain, or this methyl? This, right? So this takes a higher priority than that methyl. All right, so the highest priority on this side of the double bond is going upwards. This side of the double bond, highest priority is going downwards. So we would call it E. All right, so just in parentheses, we throw E in front of the typical nomenclature name. And that's it. All right, that's it. Let's just do another one. Let's see. Try to make a complicated one again. All right, so this one ties together some nomenclature and chirality along with our new freshly learned E and Z. Okay, so let's look at our parent chain. We have 1, 2, 3, 4, 5, 6, 7. All right, what's the prefix for 7? It would be hept. Okay. All right, but we got a double bond and a triple bond. All right. Remember, things have to take there are priorities here involved. All right. So the way that we would do this is we need to indicate where the triple bond is occurring in the parent name. Okay. So the triple bond is occurring on carbon 1. So we're going to go hept 1 ine, Y-N-E. Remember, ane is for all single bonds, ene is for double, ine is for triple. All right, so hept 1 ine. And our double bond is occurring on the 1, 2, 3, 4th carbon. All right, so we're going to have 4 hept 1 ine as our parent molecule. Okay. We also have a 3-chloro. Okay. And we have our double bond. All right, so we got to assign this an E or a Z. All right, if we're looking at this double bond, on one side of it, on the right-hand side, we have this ethyl group. Okay, coming downwards off of the double bond. And we have this other big group coming downwards. All right, so it's not E, it's going to be Z. All right, for the same side of the double bond. All right, so this is also going to be Z. Okay, and we have chirality involved in that chlorine. That is a chiral carbon. All right, so let's assign priority. All right, that chlorine is going to be a 1. All right, then this our implied hydrogen is going to be a 4. All right, what about the rest? All right, we have a carbon triple bonded to another, and we have a carbon double bonded to another. What's going to win out? That triple bond. Or no, that's going to be priorities. Yeah. So with that being the bigger group, that's going to be 2. It's going to be 3. All right. So again, if we were to just ignore our 4th priority, all right, ignore what's in the back. All right. Don't get this tripped up. The 4th priority is not always in the back. All right, but we ignore what's in the back just initially. And we connect the rest of them. All right. 1, 2, 3, that looks like R. All right. Was the thing that we ignored initially, what was dashed, was that a priority 1 or a priority 3? No. So we keep R as is. This is in fact R. All right. If your dashed was a 1 or a 3 priority, hypothetically the thing that you ignored was a 1 or a 3 priority, then you would flip what you got. All right. So let's just say, just to illustrate this, again, this is not meant to be a chirality lesson, but let's just say this chlorine was dashed. All right. We have our implied hydrogen as wedged. All right. All the priorities remain the same. Okay. Well, we ignore what's dashed, which is our first priority in this case. All right. We ignore what's dashed. 2, 3, 4. All right. This looks like R, but what priority was the thing that we ignored? A first priority. Given the fact that we ignored our first and third or a third priority, it's not in fact R, it's actually S. Okay, so that's a little trick that you can use to determine R and S so that you don't have to go through the mental gymnastics of trying to view it from another perspective or the back side of it, okay? So we found this chiral carbon to be R. All right, so we have all the pieces needed to put together in order to combine E and Z. Standard nomenclature rules are new, I mentioned our new E and Z, and chirality, okay? So putting this all together, we're gonna have 4Z, okay? 4Z, because the double bond on the fourth carbon is Z, okay? Comma, we have R on a third carbon, a chiral center of R on the third carbon, so we go 3R. And we piece the rest together. All right, so 3 chloro, 4 hept, 1 ine. Okay. All right. So again, this does not change a whole lot in terms of nomenclature, but this does just influence the way that the structures work or the way that they look when we involve E and Z. All right, remember E are on opposite sides of the double bond and Z are on the same sides of the double bond. All right, this is a concept that you need to know because I can almost guarantee on your test you're going to be given a name and you're going to be asked which of the following structures are correct. All right, or vice versa. Okay, and again, this does tie into a future lesson that will include stability of our double bonds because that does matter when we are touching on elimination reactions. All right, so hopefully this was a brief overview of getting into E and Z and how it's used in terms of nomenclature. All right, have a good one.